Yes, good morning. Yeah. So,
అది అప్లోడ్ చేస్తాను వీడియోస్.
yeah, ఈ రోజు చేస్తాను. Today I will upload. After this session
ఓకే
completed, I will upload all the videos. Okay.
ఓకే యా
And again, some study material, please, if you could.
Yeah, sure. I will upload. Today I will upload. Okay. So, yesterday we are working with so we discussed various types of queues, and also we are working with local queue, right? So, queue is the storage place, and we are working with local queue, right? So, how to create and how to delete and how to alter, okay, how to write a message and how to read a message. So we are working with this, right? So today we are working with,
Nagendra, there was, sorry, if I could ask one question here. Yesterday we had, in our office a discussion regarding this MQ itself. What this told us that the infrastructure is such that they are using multiple queue managers for one thing, for high availability. In the sense, if one is down, others is up and running.
yeah, that will see now we are that will comes into the workload distribution. Okay,
Okay, sure.
so that will you will understand in later sessions. Okay,
Okay.
high availability and everything. Okay, that will comes into the later sessions. Okay,
Okay.
workload distribution, clustering mechanism that comes into the picture.
All
Okay,
right. Okay.
don't worry. Okay, so
Yeah.
we discussed queue is yesterday we discussed about the local queue and also how to create and how to alter we are working with, right? So queue is the storage place we discuss. Okay, so one application is writing message. Okay, so first it will establish communication to the queue manager. First it will establish the communication to the queue manager, then it is writing message. Right? That's what we discussed, right? So it means this application is writing message here, from this application is reading message here. Again, so same way, for example, for segregation is required, we can use same queue, but in organization always we are using segregation. So this target application is responding back. Okay, source application is reading from this queue. That is what we discussed. So in this communication we discussed in demo also, basically here a program to program, what is a messaging here? Source application is one kind of program. Source application is, it's a one kind of programming. Means for example, this is the Java application. It is deployed on Linux operating system. Okay, and this is for example DB2. It is into the AS400 operating system. Here, the program to program communication is happening in the form of messages. So, messaging means a program to program communication we discuss. So, here we discuss two types of communication is available. One is the synchronous way of communication, and the second one is the asynchronous way of communication. So, in synchronous way of communication, what happening? The source application is sending the information means to the target application. It means it is writing message in the queue, and it is waiting for the response. It is waiting for the response. It means just I am searching for the, okay, I am searching for flights. Means how many flights are available from Mumbai to Hyderabad, okay, on 1st of March. So it is searching. Okay, means I'm waiting for this response message. That is, we discuss synchronous way of communication, right? So in asynchronous way of communication, what is happening? So source application is sending the information, but it won't wait for the response message. That is the asynchronous messaging. Okay. So target application may be immediately read, or maybe after some time it will be read. Okay. If you go for the asynchronous way of communication. Okay, and we are also discuss queue is the storage place. It follows first in and first out mechanism. So what is first in first out? For example, if the target application is not available, the messages will be lying in the like this 1, 2, 3, 4, 5. Unless until first message has entered, second, third, fourth are lying in the queue. Okay. So here, what is a message here? Message means a business data or a meaningful information carried between the two diversified applications. Okay. So this message contains two parts we discussed. This message contains two parts. Header, okay, header of the message, okay, and the header header of the message and the body of the message. Body of the message, header and the body will contain, right? So here what is the in the header of the message or descriptor? You can say header also, you calling it as a message descriptor. Okay, so what descriptor contains? Okay, so means where is the message is originated and message type, whether it is synchronous, asynchronous, and expiry option and persistency option. Okay, so here persistency is very important. So what is this persistency? Okay, so whenever source application is writing message in the queue, or target application is not available, the messages are lying in the queue, right? So unfortunately this queue manager has been restarted or my system has been rebooted. Okay, so what will happen is all the persistency messages will be recovered and the non-persistency messages will not be recovered. It means when our application is writing messages in the queue, if the message is having the persistency, those messages will be recorded for any sudden restart of the queue manager or sudden reboot of the any outage of the operating system. Whenever it has been restarted, all the persistency messages lying in the queue will be recovered. If the messages are not having any persistency, those will not be recovered. Okay, so in the message header we can find out the whether the message is having persistency or non-persistency. So okay, why the persistency messages will be recovered and why non-persistency messages will not be, why non-persistency messages will not be recovered. Okay.
Sorry, again, I did not get it. I'm sorry. So you will write this information in the header, the persistence related.
Yes, yes.
Okay.
Okay, okay.
So, okay.
Okay, so whenever the message is writing in the queue, so if the target application has to read, right? If the target application is not reading, so messages are lying in the queue. Unfortunately, any outage, so after that the persistency messages will be recovered, non-persistency messages will be not recovered. So why persistency messages will be recovered and why non-persistency messages will not be recovered? So from very first day onwards we discussed it, right? Queue manager is the object in the WebSphere MQ. Queue manager is the object, okay, which is responsible for providing messaging and queuing, right? So when our application is writing message in the queue, what queue manager will do is queue manager will check the message header. Queue manager will check the message header. If the message is having the persistency, it means in the message header if it is mentioned the persistency, so what this queue manager will do is it will write those messages in the log files. It will write those messages in the first, it will write those messages in the transaction log files. Then it will write those messages in the queue. Okay. So whenever application is writing message in the queue, so queue manager will check the message header. In the message header, if application mentioned the persistency property, so what it will do is, okay, it will write those messages in the, transaction logs. Okay, means the message, copy of the message is available in the transaction logs. So as and when any sudden outage of this queue manager or reboot of the system always whenever queue manager is started, okay, it will access these transaction logs. This transaction log contains the information of the, okay, so persistency messages and queue manager objects information. So it will recover all those things from these transaction logs. As and when queue manager is started, first it will access these log files, transaction logs. What this transaction log contains, it will contain the queue manager object information as well as, okay, persistency messages information. So what it will do, so it will recover all those messages. Okay, if it is a application is writing non-persistency message, what queue manager will do is queue manager won't those messages in the, okay, log files. Directly it will write the message in the queue. Okay, so any shutdown outage of the queue manager or system, so, okay, the after restart the non-persistency messages are not available. Okay, so here what is a message? Message means is a meaningful information. It is carried between the source to destination. So one application to the another application. So every message has two parts, header and the body. So body means actual business data of the message. Header contains the information, type of message, where it has been generated, whether it is a request and response model or fire and forget model, and the expiry option, persistency option. Now we are discussing about the persistency option. What is message persistency? If the message is having the persistency, those will be recovered for any outage of the queue manager or system sudden restart. Okay, if the messages are not persistency, those won't be recovered. Why the persistency messages are recovered? The persistency messages will be, okay, copy will be available in the transaction logs of the queue manager, because queue manager will write those messages in the first log files, then it will write message in the queue. Non-persistency messages, the copy will not be available. As and when queue manager is started, first it will check the transaction logs, then it will be started. So that is the reason the persistency messages will be recovered. Here we have to understand one thing. Queue level persistency is there, message level persistency is there. Okay, so always the message level persistency is the best option. Okay, by default in Windows it is the program files x86, IBM, WebSphere, MQ log, QM1 active. This is the location of the this transaction logs. Okay, when it comes into the when it comes into the Linux, where MQM, okay, by default path is the where mqm log our queue manager name, then active. Okay, so here we have these transaction logs for the Linux environment. Here we have transaction logs in the Linux environment. So here in Windows default is the program files IBM WebSphere MQ. So in Linux the default path is the where npm. In the Linux environment, either it may be Linux or Solaris, it is into the where npm. Okay, so, okay, so now understand the persistency and non-persistency.
Yes, Nagendra, I have a question. Where it mentioned that the log file should be under the var log npm and the queue name and the active. Is
That
that
is, it is into the
any
Linux.
way
It
we
is into
can,
Linux. Sorry.
is that we can change the path of the logs?
No, no. Once we are created, we are not able to change. Before creating, we can assign.
They
Okay.
can ask you, okay. In a
Okay.
link they can ask you.
Yes, yes. While creating of the queue manager, so I said right, see, CRTMQM, I said right, CRTMQM hyphen LD, okay,
Okay.
hyphen
Let me
MD,
give
log file path for the log file path for this,
okay.
hyphen MD data file path. So
Data.
if you mention some mount point here, blah blah blah, so it will create over there. Okay, so
That's
default is the this is the location.
this is one.
I explained right, hyphen LD and hyphen MD option, right?
Yes, yes.
Creation of the queue manager. So this log file refers to the default what -ld. If you are given some more specific non-point, it will be created
Depending
over.
on the application, we can change it.
Yeah, but once you created, it won't change. Okay.
Okay.
And Nagendra, you said that queue manager level persistency is better than, sorry, message level persistency is better than queue level. Why so? Any particular reason?
I will show you. I will show you. Don't worry.
Achha.
Okay.
Okay, okay.
Okay. So you okay. After, if I am not, I will show you that one. Okay. I am explained right. I will show you. Wait.
Okay.
Okay. So now our queue manager is strmqm qm1. See here, WebSphere MQ queue manager QM1 is starting. Okay, so the queue manager is first, whenever strmqm is the command, so it will start the queue manager. So the queue manager is associated with the installation 1. Okay, first it will verify the installation location. So 5 log records will access during the QM1 log reply phase, means it will access these log files, primary log files. Secondary log files are not visible. Whenever these are exhausted, then only it will, queue manager dynamically will allocate. So log reply phase for the queue manager complete. So any persistency messages or queue manager object information, it is there, right? So it will recreate here. Then finally queue manager will be started here. Okay. So run MQSC QM1 display queue local. Okay. Q1.lcl. So what it will do? It will display the queue attributes. So there is an option called is a default persistency, DEFPSIST. No, means by default the queue doesn't have any persistency. Okay. So I am displaying one more queue, q2.lcl. Okay. So here default persistency, yes, YESS means, okay. So I have two queues. One queue is non-persistency and one queue is having persistency. Okay. So what I am doing is now, so I am writing some messages in the persistency as well as non-persistency queues. Okay. I am opening one more CMD prompt. So AMQS put. AMQS put is the sample utility. Okay. And the queue name q1.lcl, then queue manager name, press enter. Okay. So while writing message, the queue manager should be running. So now connection has been established. I write one message, press enter. We have an option to write one more message. If we press enter again, we have a write one more message. If you press enter twice, so it has been disconnected. Okay. Now we write three messages in q1.lcl. Okay. So AMQS BCG means this is also like get call. It is it shows view of the view message. It shows a view of the message view lying in the queue, but it won't read message, just it show the view of the message. Okay. q1.lcl qm1 AMQS BCG. This is also a sample program. Our queue name is q1.lcl qm1. Press enter. So here message number it is showing 3. So 2, message number 2, and we have 1, right? So these are the three messages are there in the queue. Okay. So this is the, so we have a one specific session for this also. Okay. As of now, from here to here, this is the header of the message. Okay. From the structure ID to the original length, this is the message header. So this is the body of the message. Okay. So we are discussing about the persistency property. In the message header, if it is shown 0, okay, the message doesn't have any persistency. Okay. If the message header is shown into the 0, the message doesn't have any persistency. Expiry -1 means unlimited. Okay. It never expires. If you mention expiry, that is into the milliseconds. if you are given 1000 means here 1000 milliseconds. So what that means is application is writing message in the queue, but in the 1000 milliseconds, if application hasn't read, what will happen? Those messages will be discarded automatically. Okay, so if the message header, in the message header, if the persistency is showing 1, the messages are having persistency. If the messages are not having 0 means it doesn't have any persistency. Okay, so now what I am doing is here AMQS put q2.lcl and qmanager1. So here also I am writing messages. Okay, so AMQS BCG q2.lcl qmanager1. Okay, so here we have 4 messages. See now here it is persistency is showing 1. Persistency it is showing 1, right? It means we have 2 queues. We have 2 queues. Okay, what are the queues names? One is q1.lcl. It doesn't have any queue level persistency, no. Okay, persistency at queue level, persistency at a queue level. So by default it is no, right? So we have one more queue, called it as a q2.lcl. Okay, so okay, for this we have yes. So here now how many messages we have? 3 messages. Here how many we have messages? 4 messages. Okay, right? It means using sample program we are writing messages in the non-persistency queue. Those messages doesn't have any persistency. We are writing messages in the persistency queue. Those messages are having persistency, right? So it means the persistency message information will be in the log files. The non-persistency messages information is not in the log files. So now if I restart my queue manager, means I am stopping my queue manager using -mqm, and again I am starting my queue manager. So now if I check the my queue status, display queue status in q1.lcl and display queue status in q2.lcl. Okay, so now how many messages I am having in q1 and how many messages I am having in q2? See here, listen, I write 3 messages in non-persistency queue. So those messages doesn't have any persistency. I will write 4 messages in the persistency queue. Queue name is q2.lcl. There we have 4 messages. Okay, so the messages are lying in the q2.lcl are having persistency. The messages are lying in the q1 doesn't have any persistency. Okay, so what I did is I stopped my queue manager.
Yeah.
Okay, I stopped my queue manager. Now again I am starting my queue manager. So now what I am asking is now how many messages are there in the q1 and how q1.lcl and how many messages are there in q2.lcl.
So I think we will have just Q2 messages. Q1 should have gone out.
So q1 we don't have any messages, q2
Yeah.
we don't have we have messages. So now we will check run mqsc qm1 display queue status q1.lcl. So here current depth is showing 0. It means it doesn't have any messages. Okay, so in the same way q2.lcl. So it is showing 4 messages. Means we have a messages, 4 messages. So why the messages are in the q2.lcl, why not in? Means the messages are lying in the, here we just checked, right? The messages are lying in the q2 AMQS BCG q2.lcl queue manager 1. Here we have a persistency. Those will be recovered. Non-persistency, earlier AMQS BCG q1.lcl, okay, QM1. It throws error. No more messages, MQ close and disconnect. Because non-persistency messages will not be recovered. Only persistency messages will be recovered. Okay. So now got the difference between the persistency and non-persistency.
Yes. And again, that's clear. But could you please? I think I missed upon one thing. How do you make a queue persistent? I think you wrote some property while writing some message
Yeah,
that this.
not message.
Yeah.
So this while creation of the queue, we mentioned, right, define queue local
Mm-hmm.
DFPSAST. This is yesterday's session. Okay.
Right. Got it. Yeah.
Okay.
Yeah.
So
Level stuff, right? We haven't seen them as queue
yeah.
manager level. Okay.
Okay. So Ravi and Ganesh, you get it? You got right? This one.
Yes.
Yeah. Can you show me the same message in the log file? Because usually the practice is that we
No.
never go
This is
into that.
no. This is binary format. It won't be. It won't be. It won't be
Would not.
readable. Yeah. It won't be readable. Okay. This is in the binary format.
Same issue in Linux as well.
Yeah. Everywhere same. See, everywhere same. There is no difference. Same thing. Okay. Okay.
So it will be useful in only starting up the queues. So these log files.
Hmm.
Okay.
This
Nagendra,
this will be used for the starting.
Okay.
Just one quick question.
Hmm.
If some trade is happening, you know the trade, like not any something, this trade is happening and trade is coming with some order name,
Hmm.
and somebody say we send application say we send the order with so and so,
Hmm.
and that order is coming into our queue, and in a troubleshooting point of view, they give us an order name something, and we see the message, we see the message having that order name, unique order name.
Hmm.
In that, we have to dig into everything, like into the queue, to see the content of the messages,
Hmm.
that we receive the particular order or not.
Hmm. So you have to go through utility, or you have to browse one by one message. Okay.
Yeah, so there is any way, if there is a log file, then we easily know that okay, if we see in the log we have a persistent queue,
Hmm.
we already have a persistent queue, so we know that it maintained in the log file.
Hmm.
So if somebody asks me about the order, okay,
No,
we
no,
are sending
no,
order,
no. We won't find like that. Okay.
we can't find that.
Yeah. See, we are using security also here. That will be in the encrypted format. In queue it is not encrypted format. So the in the only batch processing scenario only the messages are lying in the queue. Other than any process, the message is never lying in the queue. Okay.
In troubleshooting point of view,
Hmm.
how do we make sure that, because if there is almost 100 messages, we
Hmm.
can't go inside and check.
Hmm.
It's a lengthy process. It's
Yes.
like a
Yes.
lengthy.
Hmm.
There should be something like we can query or we can see.
See, whenever application is writing, they are also storing which message they were sent to the queue.
No, that is like,
Yeah.
okay, if we have a server, suppose example, if we have a server maintaining a WMQ and
Hmm.
the application sends some messages
Hmm.
like a trade or something like that,
Hmm.
and trade has some unique number.
Hmm.
Okay. So whatever they do, they send a message,
Hmm.
and on that time they get a response.
Hmm.
Okay, they did not get a response.
Hmm.
And they say, okay, we put the order number like 1, 2, 3.
Hmm.
So they have 100 of messages sent, and they did not get the response of only one order.
Hmm.
How do we get troubleshoot specifically one order?
See, it won't happen. See, we discussed FIFO, right? First in, first out. For example,
Yeah.
1, 2, 3 has been processed, 4 has not been processed. It has not been read by
It means fifth
application.
one is not also processed.
Yeah, 5th, 6th, 7th is not will be processed. Okay.
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 Okay. That's
So
okay.
you have to go for the application logs. Okay.
Okay.
So here just now, so this is understand, right? So
Yeah.
in the persistency queue, non-persistency queue, we write the messages. In the persistency queue, we record the messages. In the non-persistency queue, we are not able to record those messages. I will show you the message persistency uh, in uh, in, uh, in few minutes. Okay. So this is understand, right?
Yes. This is
So
non-processed.
this is about the local queue. So then what is after local queue we have one more queue, right? So what is that queue? Alias queue.
Yes.
Alias queue. So alias queue. So what we discuss? Alias queue can't store any messages. It can't store. It can't store messages, right? So it can be pointing into queue or topic. Topic means publish subscribe mechanism. This topic has been included from version 7 onwards. For example, if you have a 5.3 and 6 version, RASQ can be pointing into the queue only. Okay, this is topic publish subscribe mechanism has been included from the version 7 onwards. Okay, so alias queue can be pointing into the queue or topic. Okay, so alias queue is a just reference to the actual destination queue. So what is the importance of this alias queue is we can hide the actual destination queue. We can hide the destination queue. Okay. In the runtime environment, we have an option to change destination queue. Without any application dependency. Okay, we have an option. Okay, we have an option to change the destination queue. It means when our application is writing message in the queue, so it will mention the queue name. Okay, so without any application dependency, we can change the destination queue name. Okay, so what it means is, so I have a queue manager. I have my queue called it as a alias queue. So here, okay, queue manager. So here I have my queue name called it as a queue alias. Okay, so here I have an application. So here I have application. So this application first of what it will do, it will establish communication and it is writing messages. When our application is writing messages, what we discussed about the open input count and open output count, right? When our application is writing messages, open output count comes 0 to 1. Open input count, okay, when our application is reading message, it comes 0 to 1, right? Okay, so when our application establishes communication to the queue alias, okay, So for example, actually what application is thinking, it established the communication to the queue alias. But here we discussed queue alias can be pointing into the queue or topic. So in this queue manager, I have two queues, q2.lcl and q1.lcl. I have two queues, q2.lcl and q1.lcl. So I created a alias queue name called it is a queue alias. It is pointing into the q1.lcl. Okay. Okay. So application is establishing communication to the queue alias. What application is thinking? Actually, it has been established a communication to the queue alias, but actually it established a communication to the q1.lcl. Okay. Application thinking, it is established a communication to the queue alias. It is just like proxy. Okay. But actually it established communication to the q1.lcl. Whatever application is writing messages, those messages comes into the q1.lcl. Those messages comes into the q1.lcl. Okay. So I doesn't want to write messages in the q1.lcl. Okay. I want to change destination to the q2.lcl. So we have a alter command, right? If you alter this alias q attributes, so then it can be pointing into the q2.lcl. So here application and there is no change. Still application is communicating with the q alias only, but the messages will be delivered to the q2.lcl. Okay, this is the way in the runtime environment we can change the destination, and application never knows actual destination queue on which queue it is writing messages. Application knows it is writing messages in the queue alias, but queue alias doesn't have any option to store messages. Got it? Hello?
Yes, got it.
Yeah.
So in that case, the Q1 and 2 both act as a topics.
No, queue only. Topic is that is different mechanism. Okay.
Okay. Okay. So what is the topic?
Yeah, topic also it comes. Okay, topic publish subscribe mechanism. That is, so
Let's subscribe.
yeah, publish subscribe mechanism. This is another kind of framework has been added. This is also we are discussing in later sessions. Okay, this is also one kind of framework. Okay, so now we are pointing into the queue. These two are the queues. Either if you have a topic, you can pointing into the topic also.
Okay.
Okay. So now here we are pointing into the queue. Okay.
Right. Yeah. And again, there be a scenario where the alias is not sort of, is unable to make connection to the actual queue. Does it happen often?
It won't happen.
It won't happen. Okay.
Okay. So run mkc qm1, define q alias is syntax. Define q alias is the syntax. Define q alias, q dot alias is my q name, my alias q name, targ type. See here, targ type, q or topic. So I am going to communicate with the queue. Target I am given a q1.lcl. q1.lcl. Press enter. So here we have q1.lcl, right? This is the non-persistency queue. As of now, we have 0 messages, right? 0 messages, right? So this is the non-persistency queue. Okay, means we created the alias queue. Define q alias is the syntax. Q dot alias is alias q name. It is going to pointing into the queue. The queue name is q1.lcl. Okay. So now what I am doing is here. Okay. AMQS put Q dot alias QM1. So we establish the communication. In the same way, just you come to here, Q's. See here for Q alias, you don't have any option, open input count, open output count, current depth you don't have, right? Right? See, current depth option, nothing it is hidden, nothing it is showing, open input count, open output count. Now where it is open output count, it is showing Q1.LCL open output count, it is showing 1, right? So see here,
That's
display Q local Q1.LCL. See here, OP proc comes into the 1. When OP proxies come to 1, when our application is connected to the queue, then OP proc comes into the 1. So what is the queue name here? Q1.LCL. But actually, which queue we are communicating? Q.alias, right? See, okay, I will write 3 messages. Okay, as of now, current depth it is 0 here. Okay, press enter. Now 3 messages. Earlier it is 0, now it is 3 messages, right? It means here we are establishing communication, means here we means AMQS put is a application. It establishes a communication to the Q alias on Q manager QM1. It is writing messages, but actually where it is routed? Q1.LCL, right? This is the non-persistency queue, right? Okay, this is what we discussed here, right? So Q alias is pointing into the Q1.LCL, so the message will comes into the here. Actually, application is thinking it communicate with the Q alias, but Q alias doesn't have any storage mechanism. Okay, now what I am doing is here, alter Q alias. My alias Q name is Q.alias target Q2.LCL. It has been changed. For example, if you display, yesterday we used it, right? All those commands we can use. Okay, Q alias. Okay, for deletion, delete Q alias. See here, target it is showing Q2.LCL. If you want to delete Q alias. Okay, Q alias name we have to give Q.alias. Okay, so now it is pointing into the Q2.LCL. Okay, so now again I am writing. So again I am established the communication. So now where it is established? Display Q status Q2.LCL, press enter. So here already we have 4 messages. Right? Here we have already 4 messages, right? So already we have 4 messages here. Okay, here as of now IP procs, OP procs comes into the 1, right? See, open output comes into the 1, means now whatever we are writing messages, okay, again I write 4 messages. So see here, already we have 4 messages here. See here, now it has 8 messages, right? Now Q2.LCL is 8 messages. This Q2.LCL display Q local Q2.LCL. This is the persistency queue, right? Okay. Q1.LCL. This is the non-persistency queue. Now in the non-persistency queue we have 3 messages. and persistency queue we have 8 messages. See here, q1.lcl is a non-persistency queue. Non-persistency. How many messages we are having? 3 messages. q2.lcl, okay, it is having persistency. Okay, so how many messages it is holding? 8 messages. Now what I am doing is here end mqm -i queue manager 1. Okay, I stop means I stopped the my queue manager. str mqm queue manager 1. Again I am started. So now tell me how many messages are lying in the q1 q1.lcl and how many messages are lying in the q2.lcl. So here we have 3 messages, here we have 8 messages. Q2 is the persistency queue, Q1 is the non-persistency queue. Now just I restarted my queue manager. So how we are having?
We don't have in a Q1
08.
0.
Here we don't have. Here how many messages we have?
8 message.
8.
Here we have 8 messages. So I started. Okay. So we have window here, right? So display queue status q1.lcl. So okay, right. We don't have any messages here. See here we have 4 messages only. In the persistency queue we have 4 messages only. In earlier we have 8 messages, right, before stopping the queue manager, right? Here we have 8 messages, but we lost 4 messages. We have only 4 messages.
When will we assign this queue as a persistent?
Sorry. So see here.
When we
See.
assign queue as a persistent?
So here q2.lcl we have a persistency, but we lost the message, right?
Yes.
So because see here we are writing messages from the alias queue. So that is the reason I said, right? So initially I showed you persistency and non-persistency, right? So means persistency, if the message is having persistency, we record. If the message is not having, we won't recover. I showed you. Okay. So I said the persistency always should be message level, right? So actually my message is generated at the alias queue level. So there my message doesn't have any persistency. Okay. That will be stored in the persistency queue, but there is no use. If the queue is having persistency, also no use. The persistency should be message level. If you are having persistency at the message level, so even if a queue doesn't have persistency, also not an issue. Okay. So see here, for example, now again I am writing messages. Okay, AMQS put q dot alias qm1. Okay, I write one more message AMQS BCG q2.lcl qm1. See here it is showing persistency 0, but the queue is persistency, but the message is lying in the queue doesn't have any persistency. But remaining 4 messages earlier we write, right? Those are having persistency. Okay, so means the message is generated at the alias queue that doesn't have persistency, but the message is stored in the persistency queue. We lost the message. The message should be persistency. Okay, so see here now what I am doing. What I am doing is
But
here.
Nagendra, Sorry, but
Just,
whatever the messages are left.
just 1 minute, just 1 minute. Okay. So alter q local, sorry, alter q alias, okay, defpsist. Okay, so here why I am using alias q is for persistency and non-persistency. I don't have inbuilt application Java or .NET. That is the reason I am mentioning here. Default persistency yes means the messages will be generated at the alias q of persistency. Target q1.lcl. Press enter. So it means now the messages are generated at the alias q having persistency. Those will be stored in the non-persistency queue. q1.lcl is doesn't have any persistency, but the messages are lying in the q1.lcl is having persistency. Okay, so now what I am doing is here I am writing messages. amqs put q.alias qm1. I am writing messages, 4 messages. amqs bcg q1.lcl qmanager1. So whatever we are writing messages in the q alias, those comes into the q1.lcl, right? Why? Because just now we are pointing into the q1.lcl. Just press enter. See here persistency it is showing 1. But here display q local q1.lcl, so it doesn't have any persistency. Okay, so now if you want to alter again, alter, so q2.lcl. Now what will happen if you want to write any message here, it will went into the q2.lcl. Now end mqm -i qmanager1. So it is stopped. Now again I am going to start. So it is started. Okay. See now. Okay. Display q status q1.lcl. So we have 4 messages. Even non-persistency queue also we have 4 messages. Display q local or display q status okay q2.lcl. So now here we have 7 messages. Okay, so it means whether queue is persistency or not an issue, the message lying in the queue should have persistency. Okay, see here I have a non-persistency queue. It has holding some messages. Okay, I am restarting my queue manager, means I am stopping my queue manager and starting. Still I am able to recover, right? Because whenever the message is having persistency, those available in the transaction logs, those will be recovered. So queue persistency is not useful. Only the persistency should be message level. So whenever application is constructing the message header, so it will mention the persistency equal to 1. Okay. Yeah, Vikram, now ask me.
Yeah, my question was related to the first scenario, where you talked that only 4 messages were saved and the rest were, gone off. But the question was, how did we achieve the persistency at the queue level? Sorry, at the message level. That's something I could not get, to be honest.
That is application error. Don't you confuse your talk here. That is always application level. Just now I said right. Application will mention message header persistency equal to 1. Just 1 minute back I said.
No, you said, but I did not get. That's what I'm asking. So my question is, forget about the application when you're seeing that, but in message level, how do we achieve? You said you made a alias and you created, persistency level there. Is that equivalent to message level persistency? Can we say that?
Hmm.
So,
I don't have application. That is the reason I showed you through uh, through
sorry,
alias.
alias level, yeah?
Hmm.
Okay, so when you create alias and you just create the persistency in the alias, that is equivalent to create the persistency in the message level. We can say that, yeah?
Hmm.
Okay. Okay.
Okay.
So in application, we will just write persistency is equal to 1 in the message level, yeah?
Yes. Application persistence equal to 1. Okay.
Okay. Okay.
Okay.
Okay.
So
Yeah.
this is the alias queue. So alias queue. So here it is hiding actual destination queue, and in the runtime environment we have an option to change the actual destination. So in application end we don't have any changes. Means there is no dependency at the application end. Okay.
Right. Yeah. But in Java, etc., can we just write persistency equal to 1?
Yeah,
And
any
again,
program while constructing, so they
yeah.
will mention persistency equal to 1. Then all the messages will have whatever the application is putting, those messages even persistency. If they
Okay.
mention, they haven't mentioned the persistency property, so by default it is into the 0, doesn't have any persistency.
Okay, sure. Nice.
Okay. Okay.
Yeah, thanks.